Noisy Children, an investigation into how to reduce background noise for remote learners. Welcome to my science fair. Throughout my time as a full-time distance learner at IPS, I've experienced the difficulty of sound in the school's classrooms. From the horrible sounds of a class outburst to the ear-piercing dropped pencils, it becomes very difficult to hear the things that you want to hear, like the teacher's voice. So in my experiment, I decided to try and determine what material is the most effective at blocking classroom sounds, with a focus on high-pitched ones. The material I used in my experiments, at least for the test materials, were heavy felt cloth, light cloth, corrugated cardboard, and non-acoustic padding, with my hypothesis being that the heavy felt cloth will perform the best. Some other materials or pieces of software I used were Audacity, a free-to-use open-sourced professional audio processing software, my desktop microphone, which is right here, a plastic bin, my personal computer, Microsoft Excel to display my data, some speakers, and Scotch tape. As I describe my method, I will play a time-lapse of my trials. So first, I set up my microphone and let the speaker dangle from my desk. I also made sure to point the speaker in the direction of the test material, so that I could really see the difference between them. Then, I applied the test material to the sides of the bin. Some of them required Scotch tape, some of them didn't. There he is. And played the clip at near at a very similar level to the sound I experienced in the classroom. I'm just going to quickly let it roll for a little bit, just get an idea. That was early on when I was trying to figure out how I was going to set all this up. Anyway, next we have a quick overview. Before I show you my data, you must know how electronic decibels work compared to physical decibels. A quick summary is that sound traveling in the air can only be measured in positive decibels or 0 decibels. Electronic decibels work very differently. The decibels used in my data and graphs are negative. They are negative in the sense that they are less than a predetermined numeral, and in my experiment, that predetermined numeral is 100 decibels. So in order for my data to be easier to understand, I've labeled negative decibels as decibels reduced. So on my first graph, now onto the data. The graph you're seeing right now is the average decibels reduced of all the frequencies tested, with the light cloth being quite surprisingly the most effective overall, with my hypothesized best performing material coming in second. Now onto my more complex data. The graph you're seeing now is the decibels reduced of 4 different frequencies: 175, 1000, 3000, and 7000 hertz, with the lighter tones of blue being the higher frequencies, with the voice of a teacher being about 175 hertz, and the annoying sounds being 3000 and to 7000 hertz. Most materials are equal when it comes to 175, but there's a notable difference when it comes to 1000 hertz, which could be something like a very high-pitched scream or angry yelling, with the light cloth being the most successful. The really high-pitched sounds is where cardboard does a lot better than in the lower, compared to its lower figures. While padding seemed to amplify these sounds compared to the control. Although I had originally thought that the heavy cloth would do the best, it was not far off at all. I'll just give you a moment to look at the graph. Maybe that'll help it hit the 4-minute mark. You never know. Okay, you looked at it great. Alright. Thank you for watching.